Hello and welcome to my tutorial series. Today we'll be expanding upon our 2.5D platformer game. Hopefully you should, by the end of the previous tutorial series, have a 2.5 platformer that looks a bit like this. We've got our character that's just a cylinder at the moment. Maybe you made this look nicer than the version I have. Can you tell I'm a programmer from how little time I spend on what my games look like in their prototype stage? So we can jump between these platforms, and our character is followed by the camera, and they can also die when they fall into the lava. The next thing we're going to want to do before we add in like enemies, goals, collectibles, that kind of stuff that we're going to be having a look at. But before we do that, I want to have a look at our movement to see if we can improve just a little bit. It's a slightly advanced concept, but what we're going to do now for the player's movement is rectify a problem that exists. Some of you may have encountered this problem in your game whenever you were running it. It depends on your frame rate. But basically, there's the potential for the character to jump more than once within a single frame, which means that if you're on the very side of an object, not sure I can create this bug in my version because my frame rate is so unbelievably high. Look. But there's a problem where you can jump off the sides of objects, etc. One of the reasons that there's a problem is that we are doing everything in fixed update, which is great because we're interacting with our physics object. We're causing our player to move through physics. And so that makes sense. We want to be changing things in fixed update and not update. However, there's one thing that we don't want to use fixed update for, and that is our input. If you imagine that the game runs at two different frame rates for physics and for everything else, for every normal frame that the game renders, there might not be a physics update. That means that the physics, because it takes more computational power, it takes longer between frames for it to update. So what happens whenever we press our space bar in a frame that is not a physics frame? Well, nothing will happen in a fixed update method. If we change this from get key to continuously check if you have the key space down to what we really should be using, which is get key down, we only want to jump the once when you press the key down. Sometimes you won't jump when you press the space bar because in that particular frame there wasn't a physics fixed update frame. I just pressed the space bar there, but my character didn't jump. Let's rectify that and use some booleans. We'll now be using booleans to store temporary data that we can then use between our fixed update and our update. So for example, we can have a bool which is has jumped. That's too ambiguous. Has pressed jump button instead, because that's exactly what it is. Oh, and we forgot we have to tell it what kind of variable it is. It's going to be a bool. Now we can make, as well as our fixed update, let's make a normal update method. So this will happen every single frame, regardless of whether that frame is calculating the physics or not. Then we'll take our get key down space and put this, we'll get rid of it from our fixed update and put it into our update method instead. Oh, Visual Studio is auto-fulfilling in a whole bunch of stuff I don't want. I don't want this, I don't want this. And we do want the little normal bracket here. And now instead of having a direct link between us pressing the space down, button down, we're instead just going to set our boolean. In this case, we're going to set it to true. So now we've got our input that is being calculated every single update frame instead of just the fixed update frames. Now we can use this variable as our new if condition. Finally, we want to make sure that we set this to false if we do use it. That way, in our update frame, we're setting it to true when we press the key down. That means we'll definitely find that input every time it happens. And then in our fixed update frame, which might be immediately after or might be a few frames later, we'll check if we've pressed that button. If we do have pressed the button, we want to set it to false because we've basically used the input, and then we'll do our jump. So now it's kind of hard for me to show this to you, but you might notice it yourself by playing the two different versions. Now every time I press the spacebar button, my character should jump. But what's going on? Well, because we fixed the problem of jumping only once, actually the force that we're jumping with isn't enough anymore, because in the previous wrong version of the game, we were jumping with such a small vector because we were jumping in many different frames. So we actually now need to increase our jump value. In this case, maybe I increased it too high. But now at least we know that every time we jump, we're definitely not jumping multiple times within the same physics frame. 600 was too high and 60 was incredibly low. I'm going to go ahead and ballpark 400 being a good value for this jump. It's still pretty high, but let's keep it like that. We can tweak all those variables later, but for now we're going to try and implement some more functionality based stuff. So we've fixed up our movement a little bit. Let's move ahead and think about how we can turn this platforming into more of a video game. One of the things that we could try and do is implement some elements, more elements of challenge. At the moment, the only thing that's challenging is jumping between the platforms. What if there was something we also had to avoid? I'm going to go ahead and we're going to create something very abstract. We can always replace these later, or maybe you already have replaced these yourselves with other art assets. In this case, I'm going to create a sphere, and this will be our evil enemy sphere. This is prototyping at its finest. All right, let's at least make a new material for it. It's like the evil material. What's usually a big warning? Red. All right, you don't want to hit a red thing. It's ingrained in us not to. So, how are we going to make this red object something that we die from? At the moment we can jump onto it. We don't want that. We want it to be death. So just like our floor is death because we've got the death collider attached to it, let's go ahead and add a similar death collider to our object. We'll have to set up the player again, so I'm going to drag this player in. And there are lots of different ways we can do this, but this is the one we're doing now. It's very simple. Now when we run the game, we will die whenever we jump into it if we don't avoid this sphere. Oh no! We're probably going to want to add a live system so that we don't just insta-die, but we'll do that later. Now let's think, okay, well, if the static sphere isn't that interesting, maybe it'll be more of a challenge or an interesting challenge if the sphere is moving. So this will, I'll scale it down a little bit as well. This will introduce us to using timers. I'm going to add a new script and it will be something like enemy. I'll just call it enemy. So this will be our enemy script. I've attached it to the object. We're going to open this up. And now we're going to use timers to move our character. In the future, we'll use more complex AI, but for now, we're just making a 2.5D platformer. We're just going to move our character back and forth across the screen. So how are we going to do that? Well, whenever you think about the character, the enemy, and how it's going to move, it needs to know a couple of different things to be able to move. It needs to know what direction it should move in. So in this case, our direction is going to be a vector3 variable. So direction, let's say left, it moves across our screen to the left. But if we want our character to move back and forth, then we'll want them to be able to move right as well. So let's make that a direction variable as well. Now, which way is the character going to move? Well, if it moves back and forth, it's going to sometimes move to the left, sometimes move to the right. And we're going to have to keep track of that. Well, we're either moving in one of two directions, which means it's a binary. It's either one of two values, which we can track with a bool. So let's go ahead and call this something like movement direction right. So every time, if this is true, that means we're moving to the right. If it's false, that means we'll be moving to the left. We could move this character just in the update frame because we're not going to use physics. We're going to have this object just float in midair. So we can just move them in the update frame instead of fixed update. Let's go ahead and instead of using our rigid body to move the character, we can just directly change their X position. So to do that, we're going to go to the transform of our object, transform dot position. And now we're going to set it to a new position, which is equal to its old position plus our direction. So let's say if we're going right, we're going to add our right direction velocity. So it's setting it to itself plus the new value. We could also do this with plus equals and get rid of this bit. I'm going to keep the long form version just so it's more readable. And finally, we're going to want to multiply our direction with time dot delta time. That way our movement will not be frame rate dependent. Well, let's see what happens when we run this. Well, currently the red orb is not moving. Very disappointing. We've probably forgotten to do something. You may be screaming at me already. Let's go ahead and actually set the value of our direction. So moving left is probably going to be like minus 10 on the X value, and moving right will be 10 on the X value. At least I think that's the axis that this is moving on. And I can check this by looking at this X value that changes when we move along this axis. So yes, I think that is correct. I'm going to go ahead and run the script now. There he goes. Very quickly, in fact. Maybe we'll want that to be slower, just especially now when we're testing it, so we can see it move more slowly. So we're just moving our character to the right. So when should the character move to the left? Well, let's use a timer to work that out. So we're going to be using a float variable to keep a track of that time that's passed. So we're going to call this direction change timer, let's say. And okay, well, how often should we change direction? That's going to have to be another value as well. In this case, we're going to say direction change time. So basically, one of these will keep track of the amount of time that has passed, and the other will tell us when we should change, when we should swap direction, how much time needs to have passed before we swap. In our update frame, we're going to increase the value of this timer. And we're just going to say plus equals time dot delta time. That means that every frame as the game runs, the timer will just increase and increase as the time that has taken place in the game continues. We keep on adding time dot delta time. Now we're going to want to add another if condition. And this time we're going to check, is the timer greater than or equal to our direction change time? What this does is compares these values, has the time that's elapsed, is it greater than the time that we are setting for when it should change. In this case, the timer will get higher and higher and higher, and then it will meet that threshold as it gets checked every single frame. And then when it's true, well, what do we want to do when it's true? Let's have a look. We're going to keep track of which direction to move with this Boolean variable. And so this is the thing that we want to change. So if we're moving left, we want to now change to move right. And if we're moving right, we want to change to go back to moving left again. And we can do this by setting the value of our Boolean variable to the opposite of its current value. And there's a nice little exclamation mark, which means the inverse of a Boolean variable. So we set it to the opposite of what it currently is, itself plus this little exclamation mark. We also want to reset the timer so that it can start again, and then our Boolean value will change. Let's go ahead and set it to 0. Then the timer will start again, and then it will hit the new direction time. It'll get set to the inverse value, And this will keep on going over and over again as it flicks between the two variables. So we're going to want to look at our variables in Unity's inspector window so we can see them changing. And at the moment I can't see them because I maximized the screen on play. So I'm going to turn off maximize on play and then run the game. And now I can click on the sphere and see the variables change as the game runs. So it's still just moving to the right, and that makes sense. We haven't actually got any logic to change in what direction we're moving in. But we can see that the Boolean variable is just flickering between true and false. And that's because we haven't set our direction time yet. So because the time is 0, it takes 0 frames for it to swap, and then it just swaps instantly every frame. Swap, 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 swap. Let's set that value and make sure we do that when we're not playing the game. Let's say 3 seconds. Every 3 seconds it will change direction. Let's run the game again. So you can see the timer goes up to 3 and then it sets it to true. Timer goes up to 3, it sets it to false. Timer goes back up to 3, it sets it to true, and so on, and that will just keep looping. Alright, we've got our Boolean, which determines what direction it should move, and that seems to be working with our timer. Now we just need to actually change the direction of the enemy based on that Boolean. Well, we just have another if condition. If the direction is moving the right, so here's our Boolean that we're using, movement direction is right, well then we'll want to do this thing that we've been doing all along, which is moving to the right. However, if it's not moving to the right, and I'll use this little exclamation mark here, so if it's not the case that we're moving to the right, we want to do the opposite thing, which is add our direction left. Now, if any of you guys are particularly experienced with code, you'll be maybe saying to me, that's not what you do all these other things. But this is, I'm not using an if else, I'm not using switch, blah, blah, blah. Point is, this works, and it's the simplest with the things we've already learned how to do. So I'm going to save this. These are basically just the same thing, right? We're moving ourselves, or we're moving the red orb anyway. In one case, we're using the right when when this Boolean's true, and we're using the left direction when it's false. So let's run this. And now we've got the character moves to the left, and now the character moves to the right. They're not moving very fast, so it should be easy enough for me to jump over them. But it's slightly more challenging. Oops, I say that and there I go. I failed at my own game. Alright guys, that's the end of part 1 of this tutorial.